So thank you again for joining us for an Autodesk Design and Make webinar as part of the webinar series for educators. This one is called Design and Make with Lasers, and we have a number of exciting topics and skills that we'll be covering, of course, revolving around manufacturing techniques with not just laser cutters, but a lot of different types of manufacturing techniques using similar skills that we can bring into the classroom. So lots of exciting things to chat about. My name is Jason Erdreich. I am an educator and tinkerer and all-around maker of things, and I've teamed up with the Autodesk and Tinkercad team to be able to provide training resources like this to educators like you. And I am joined again by my co-host, Nicole. If you want to say hello.
Hi, I'm Nicole, and I do community support for Tinkercad and Instructables. So I get to help people out and see what everybody's up to every day. So it's great.
Yeah, awesome. So thanks, Nicole. I'm glad that she is again here on the front lines with me as a co-host. Normally, she's working super hard in the background to make sure that we have all these great links. And Nicole's gonna be working to make sure that everything I say has a follow-up link, so you'll have some good resources and takeaways and things like that. And before we get into the content, a couple background things in case this is the first webinar, in case this is a new thing to you. We've been running this webinar series for a few times now, so this is our 6th webinar, and again, it's called Design and Make with Lasers. And looking ahead, our next webinar will be on May 9th, and it's building digital skills for architecture and construction, which will be super cool. Lots of real world activities and things like that. And every single webinar that we've run, not just in the Design and Make series, but in our past webinar series called Teaching with Tinkercad and Level Up with Fusion, have been recorded. And this webinar is being recorded. So you can always go back and see past webinars if you missed them on the Tinkercad YouTube channel, which I'm sure there'll be a link in the chat sooner or later for you to check that out. And this webinar is being recorded as well. So while we'll be covering a lot of different content very quickly tonight, as we only have an hour to work together, we will be, of course, sharing this recording so you can go back and review all the content, watch it at your own pace, share it with maybe folks who missed it that you think might be interested as well. So this webinar is being recorded, and the slides that you see are also going to be shared as well. So tomorrow we're going to send a follow-up email that has a recording for the webinar, as well as the slides that you see me working with, as well as a couple other really useful resources too. So just note that that will be coming to you. And how to participate. So there's, of course, a lot of you here, which is absolutely fantastic. And the best way to participate is to use the Q&A. So the Q&A button on your Zoom will allow you to ask a question, which I see some of you are already using, which is fantastic. And the nice thing about the Q&A is the question will stay there until either myself, Nicole, or sometimes some other Tinkercad team members join us, answer it. So then that way you can, of course, use the chat, and we'll be using the chat to drop links and sharing things to you. But as you'll notice, the chat moves kind of quickly, so we don't want to miss one of your questions. So if you have a question, please drop in the Q&A, and that will allow us to answer it. That also allows everyone else to see the answered questions as well. And at the end of the webinar, when we go through all the content, we'll have an open forum Q&A, where again, we'll stick around for the last few minutes here and just allow you to keep asking questions to follow up on the things that we covered as well. And again, this is being recorded, and these slides will be shared with you as well. So Design and Make. So this is a series that we launched because when we are working with Design and Make, we find that teaching with Tinkercad allows us to talk a lot about Tinkercad and the amazing things that Tinkercad can do. And Level Up with Fusion was a similar series that allows us to talk about all the great things that you can do with Fusion. But what about everything in between? What about the different projects, the different learning resources, the types of activities and instructional resources and things that students can engage with, as well as all the things that you as teachers need to support those students, like rubrics and instructional resources and challenges and things like that. And that is what Design and Make is all about. Talking about all the amazing things that your students can use, the tools that they can use to empower their ideas, to bring their ideas to life and really design and make anything. So that is exactly what we want to do. And in tonight's webinar, we're focusing on designing and making with lasers, as well as some other things. It's called Design and Make with Lasers, but we're going to slide in some other important content as well, because these skills are pretty universal and can connect with a lot of different things. So first and foremost, what is a laser? Well, this describes a machine that uses a beam of light to cut and engrave and remove material. So lasers come in all different sizes. So there are small little desktop lasers. There are huge industrial lasers that are used to manufacture tons of products and things like that. And I'm specifically talking about beams of light used to do cutting and manufacturing. So there are, of course, other types of lasers, like laser pointers and laser cameras and those types of things. That's not necessarily the same type of light that we're focusing to actually use for manufacturing processes, but it is a tool that can be used to manufacture parts. And as we talk about our manufacturing groups, there are really three manufacturing groups or three groups of machines that are commonly used in mass production. We have additive manufacturing, where you add material to make a product. This is where 3D printers live. So 3D printers will either melt rolls of filament or harden liquid resin, and it will build over a time. It will continue to build material like layer by layer, and that's adding material to make your product. Subtractive manufacturing, you would put in your material, like put in a block of wood or a piece of plastic or a piece of metal, and then that machine would then remove it either through a carving method, like for example, using a carving mill, which can cut away material. And we talked about that in one of our Level Up with Fusion webinars when we learned about CNC production, or a laser would actually burn. Using an engraving process to burn away material. And then, of course, there's formative manufacturing, where you might have some type of mold and you pour your material, usually a liquid plastic or something like that, into the mold, and then when you take the mold away, you have your part. And these are used in all different forms of manufacturing. And as we go, and as we work through this, again, as we talk about laser, as it's important to understand that there are a lot of different types of subtractive manufacturing lasers, and they vary based on size and primarily the types of light sources that they use. So the smallest and the most affordable laser is typically a diode laser, which really uses a really high-powered like diode, almost like an LED light bulb, but it's of course it's more intense than what you might find in a flashlight, and it's a focused beam of light that can really engrave. Diode lasers don't really cut very well unless it's thin cardboard and paper and things like that, but they can engrave very well, and again, they're very affordable. Another really common type of laser, and a slightly more industrial one, are CO2 lasers, which uses a tube of essentially charged particles and CO2, and it focuses that beam of light. And these lasers are way more industrial, so they can cut and engrave much thicker materials, typically up to like half-inch wood or so, or give or take 5-6 millimeter wood. Or more, depending on the power. Again, they come in a lot of different sizes, and they might be able to like etch metal. They might be able to etch aluminum, but they really don't cut metal very well. To do that, you would need an even more industrial type of laser, like a fiber laser, which can cut metal, or plasma, which technically isn't a laser, but it kind of falls within the same category, because again, we're using different types of light sources or beams of energy to actually go ahead and cut through our material. And plasmas are much more industrial and do cut through metal, and is used to make a lot of different types of metal products and things that you might see. So as you are choosing the laser for, let's say, your instructional space, if you don't have one, as you can see, there's a lot of different options, and you would essentially kind of have to weigh your budget to purchase one, as well as the types of projects you want your students to be doing, as well as the type of space that you have, right? How much room do you have for these types of things? But just note that you have lots of options. The other great thing about lasers is they work with a lot of different materials. So you're not just using a laser for plastic like you might be with 3D printing necessarily. Many lasers are able to cut and work with paper, cardboard, wood, foam core, acrylic, a wide range of materials, and they also operate rather quickly. And I personally, this is just some of the projects that I've taken from my makerspace here. And I use lasers in my classroom for many different things, lots of different projects. One of my favorite projects for my older students is challenging them to make their own ruler and then use that ruler for the rest of the year, which is a good way to also teach CAD skills. But even using lasers just to make things for my classroom, of course, like sign out stations or rigs to launch rockets and organizers and whatever it might be. This bottle holders from my home, not for my classroom, but again, just making things for around the house. So it's a really versatile machine that allows you to work with a wide range of materials. Now, I mentioned earlier the term CNC. So CNC stands for Computer Numeric Control, and it describes a process of using a computer to control the movement of a machine. And there are a lot of different types of CNC machines, and all CNC machines kind of work in a very similar way, So CNC machines essentially allow us to use computer code, a coded file, to manufacture our different designs. And when we say the term CNC machine, we're usually referring to either a mill or a router, a lathe, a cutting machine like a laser or a vinyl cutter or a water cutter or a plasma cutter, or a 3D printer. And I bring this up because while these machines perhaps operate in a different way, and while they potentially allow you to work with different materials and also allow you to work with a wide range of projects, the skills that your students would have to learn are very common. So, for example, designing for a laser cutter is a very similar process to designing for, let's say, a vinyl cutter to make a decal or a t-shirt. So I know many of you attending this might not own your own laser, and that's perfectly fine, of course. I'm glad that you're here to learn about what they can do and how the skills that your students are learning can allow you to access these types of things. But just note that these skills aren't only for laser cutting. They're universal for these types of machines. So I'll show you later on how you could do something similar, let's say like a vinyl cutter to make a vinyl sticker. And even still, the types of skills that allow you to work with laser cutting can also be used for, let's say, 3D printing or working with mills as well. So teaching our students manufacturing processes as general is a really fantastic universal skill that they might learn how to use one machine in your classroom and then go off and have a future career and be able to transfer those skills to an entirely new experience. Now, what makes lasers unique compared to some of these other CNC machines is that they're actually two-dimensional. And that doesn't mean that we're only making perfectly flat things. Of course, there's three-dimensional to any physical object we can hold, but they only have two operating axes, typically. And what I mean by that is the types of travel our machines can do are called axes. So for example, a 3D printer, which I think many of you might be familiar with, can travel in three axes. It can move left and right, which might be X, forward and backwards, which might be Y, and of course up and down, which might be Z. A laser typically just moves in X and Y. And the three dimension of your part that you make with the laser actually comes from the thickness of the material. So let's say I put in 1/8 inch or 3.175 millimeter wood in my laser. That's how thick or how tall my part will be. So that's defined not by the laser, but by the material that we use. If I put in thicker material, my part will be thicker or taller, right? And they are two-axis machines. Now, that said, there are some lasers out there that can do some really cool three-dimensional things. And these are far more advanced design features. This is also a much more industrial laser that can do this. But you can see that the laser actually created almost like a CNC carved pattern. And it does this by essentially varying its power. And this happens less in the design stages. So a student might just design 3D as a very simple model. To do a design like this and to manufacture in 3D like this happens later in the CAM and the manufacturing stages, and we'll talk more about that later on. Now, before we dive into actually how to design for lasers and get into some hands-on projects, let's talk laser safety, because if you are considering getting one, there's a few things you need to know. So first and foremost, as I mentioned, all lasers use a beam of light of some type, varies, to cut things. And those light sources or those emitted lights can be harmful to your eyes. So a couple things that you need to consider is, first off, a lot of lasers have a tinted and a protective canopy. So the glass would actually kind of be covered, and it would allow you to look at the laser, and the glass is tinted, and your eyes wouldn't be put at risk. If your laser is, let's say, open and not enclosed, you might need to be wearing laser protective safety glasses like the ones I have on the screen. But just always note that staring at a beam of light with unprotected eyes is, of course, dangerous. And that's not just lasers, that's sort of a general rule, but lasers especially. Lasers also, again, remove material by burning. So it's through a burning process. It etches material away. So that means that there's a byproduct of smoke. So we have to make sure that the exhaust of our lasers, those harmful fumes from burning material, is evacuated. And if you have the ability to ventilate the laser outside, let's say that your room is against an exterior wall and you can vent the laser outside, that is the best case scenario. There are also in-room filters. So if you can't do that, there's in-room HEPA filtration filters and things designed specifically for lasers. But it's not just like needing a vacuum to dust collect. It is actually evacuating the harmful fumes. That's the byproduct of laser cutting. And then there are some materials that cannot be laser cut. So if there's a material that when it's burnt will emit toxic gases, like let's say, for example, PVC, you don't want to burn PVC, right? So you have to make sure that the materials that you're using in your laser And as I mentioned, there's a lot of different materials that you can use, but you have to make sure that the materials that you're using, the glues or the resins that made that material, are not toxic, or else burning them could be hazardous, even if it is being vented. So a couple unique safety things that we need to consider for working with lasers, especially in the classroom, that we don't necessarily have to consider with other types of manufacturing processes. Now, let's get into how to design for these things, right? So we have two programs that we'll talk about tonight. We have Tinkercad, which is fantastic for younger students or students just getting started with CAD. And then we have Autodesk Fusion, which is a much more industrial, much more advanced CAD program, which is well suited for students at the high school age group. So both of these applications can be accessed via an app or a browser. So you can log on to Tinkercad or Fusion in the web browser on pretty much any device. Tinkercad also has a wide range of apps for tablets and things, and Fusion has an offline version for Mac and Windows computers. Autodesk Tinkercad and Fusion is completely accessible for free for students and educators. So anyone can go to Tinkercad and just sign up with either an Autodesk account, or by making an account for free, or by signing in with one of the supported accounts that you can see on the screen. Teachers can also create in Tinkercad classes, and you can actually make accounts for your students. And we talked about that in a past webinar that you can go back and check out as well in the link that we shared earlier on. So let's say that you have younger students and you want to be able to manage their passwords. You can actually create their accounts in Tinkercad as a teacher. And again, even for Autodesk Fusion, you have to create a free account to be able to access it, but both teachers and students can access it, although there are age restrictions based on your region. So for example, in the United States, that would be 13 years or older. And again, that would vary depending on where you are for Fusion. Teams and classes are two different resources that do a very similar thing. So in Tinkercad, you can create a class, and this would allow you to have your students join your class. You'd be able, as a teacher, see their work, go into their assignments, provide feedback, things like that, and be able to see what students are working on. And in Fusion, we call that teams. So you could create a team in Fusion, invite your students to it, and students, again, can be sharing their work with you, sharing their work with their classmates. You as a teacher can kind of keep an eye on what they're doing and give them feedback as they are working through their projects. And in Tinkercad, we have three different design spaces: 3D design, circuits, and code blocks. We're not really going to be talking about circuits or code blocks tonight, but we have past webinars on those. Tonight, we'll be looking specifically at the 3D design space as we go to create things for laser cutting. And Fusion has a number of design spaces as well. So spaces for designing, manufacturing, creating electronics, simulating how your parts might perform, generative design, which is using AI to actually enhance our designs, and of course the collaboration tools like Teams, which I mentioned. And tonight we're really just going to be looking at the design space and the manufacturing space. But again, we've talked about a couple of these things in past webinars that you can always go back and find some more information on. And you may have noticed that there are some hyperlinks in this slideshow. So we will be, of course, sharing this slideshow out with you, and there's a bunch of useful links and resources linked throughout as well. And there's also another cool feature, which I will show you in just a few moments, which is how to send your designs from Tinkercad to Fusion, which will allow your students who maybe have been working with Tinkercad for a long time and are ready to kind of elevate their skills to a higher skill level. They can easily transfer their designs from one program to the other to be able to access the more industrial kind of career-focused skills and features of Fusion. And the reason that you might want to do that is, of course, Fusion is designed to mimic what professional designers and engineers are doing. So Tinkercad is designed to be a very easy to learn, very intuitive design program for students of all ages to kind of get started with CAD and manufacturing. And then Fusion is designed to allow students to access all the tools, all the resources that a professional designer or engineer might have, so they can really bring their products into that real world scenario. And again, tonight we'll be looking at both from the lens of designing for lasers. So I'm going to flip my screen, and I'm going to head over to Tinkercad first. We'll look at Fusion in just a bit here. All right, so I'm signed into a Tinkercad design, and I have just an empty 3D design here. And if you've never used Tinkercad before, we're in the 3D design space. And the way that the 3D design space works is that you can essentially grab these different shapes, and I can manipulate the shapes. I can kind of lift them around and move them as I go. And you can see that there's measurements on the corners of the shapes here. I'm currently working in millimeters, but I could change my unit, and I could work in another unit if I wanted to. And if I wanted to, I can actually click on these dimension boxes and punch in dimensions for my model. And I can grab multiple shapes and I can combine the shapes. So for example, if I were to grab this cylinder shape and put it on the corner of my box shape like this, and if I were to select both these shapes and group them, I now have this solid part as well. And in addition to having solid shapes, you'll see that we also have this option for hole shape. So if I ungroup this and if I turn the cylinder into a hole, and now I group my two shapes, I actually cut. So we can use hole shapes to cut into solid shapes and solid shapes to make solid parts for our design. Now, the biggest difference I need to explain, typically when people are just getting started with laser cutting or designing for, let's say, vinyl cutter or something like this, using a 3D design application like Tinkercad's 3D design space we're in now, to design for 2D can be a little difficult to learn at first. So for example, let's say that we want to make a box. Okay, so I'm just going to make my box a little bit bigger. All right, and I'm going to hollow out my box. So I'm going to duplicate this. I'm going to make this a little bit taller and a little bit smaller and raise this up a bit and set this to be a hole. I'm then going to select both shapes and use my align tools to align my shapes. And when I group them, I have a box, right? So here's my box. Now, if I wanted to 3D print this box, I could just hit export and download this for 3D printing. And I could 3D print this box, assuming that my 3D printer was big enough to print it. But if I wanted to laser cut this box, I can't do that. And that's because my laser can't make, we learned that lasers are really two-dimensional machines. They can make 3D things, but they can't necessarily make a 3D thing like this. It can't add material, and I might not be able to fit this. So if I wanted to make a laser cut box, I'd have to design this in a completely different way. So I'm going to leave this box off to the side. This is our 3D printable box. If I want to make a laser cut box, I would actually have to design this in, let's say, flat panels, where I might make a wall like this, and I might copy this wall a few times. Let me rotate this around. Line up my walls here, copy this again, and let me just make one more copy, and we'll give ourselves a bottom of our box. I'm not really putting too much time into my measurements right now, so forgive me, but this is also a box, albeit slightly bigger because I didn't measure it. Let me scale this down a little bit so they sort of match, right? So this is a solid box that could be downloaded for 3D printing. This box has been made out of panels, flat panels. And if I wanted to, let's say, laser cut this box, right? What I could do is I could take my panels and I could space them out and lay them down flat for manufacturing like this. So I might design my box in 3D, how I want it to look. And what the laser would need, because again, lasers are two-dimensional machines, is it would need a flat, sort of like a flat packed design here, where I have all of my pieces for my box laid out like this. And then what I could do is I could cut these 5 panels out of, let's say, wood or something like that. And after I cut those 5 panels, I could then assemble the box to be 3D like this using glue or something, right? So they would fit together. And that's the biggest difference. Like with 3D printing, with laser cutting, you can make very similar things. Again, we can make boxes, we can make, name tags or keychains or lots of other types of projects, parts for catapults, etc. But 3D printers are adding materials, so you can make solid 3D shapes like this. For lasers, we kind of have to think in terms of two dimensions, right? So again, designing these flat panels like this. And that's the biggest difference here as we're considering designs. Now, the next thing I want to talk about is what does the laser actually see? Like when we go and download. So I don't really need these boxes, so I'm going to throw them away. And I'm just going to keep one of these panels, right? When you have a design in Tinkercad and you download it for laser cutting, all the laser sees is what's touching the work plane. Because essentially what happens is your design is flattened, and the part that's touching the work plane is what the laser will see. So for example, let me make this part slightly more interesting. Let me add, let's say, 2 holes to this plate, like this, and let me grab another cylinder. Now, if I raise this cylinder up off the work plane like this, when I download this part for laser cutting, it won't see it at all. Because again, it only sees the features that are touching the work plane. So for example, I'm going to switch back to my slideshow real quick. Because as here you could see, here's the design in Tinkercad. When I export it, this is all the laser sees. It flattens this red box here, and I can see the box, I can see the holes, and all the laser sees is that 2D profile of what's touching the work plane. Now, if I head back to Tinkercad, which I'm doing slightly slowly, here we go, back to Tinkercad, right? Let's say that I delete this cylinder, and let's say that these holes don't actually cut all the way through, right? They just sort of score the top. All the laser is going to see is, again, what's touching the work plane. So it's not even going to notice that these holes are here. So if I switch back to my slideshow, just because I've already prepared this for you to take a look at, we can see that this design, when it's exported, is just an outer box. Because again, when we download for laser cutting, it downloads just a two-dimensional profile of what's touching the work plane. Because we often have students that are designing amazing things, like really cool designs, really cool features in their Tinkercad models. And while I certainly, I'll try to make something kind of cool right now, sort of quickly. Let's say that I make a really elaborate design like this, and it's 3-dimensional and looks kind of cool. And I don't know, there's some type of cool cone thing happening over here, right? I don't know, some type of crazy shape. And I group all this together. If I were to download this for laser cutting, and let me just fix my cone because I'm actually poking through, please hold. Okay. If I were to download this for laser cutting, all that would be seen is what I can see from the bottom, right here. And to emphasize this, I'm going to turn off my little work plane just temporarily. This is what the laser would see. It would miss all of these parts that are sticking up, right? So the height of the model, all that's kind of irrelevant. Let's say that I really was trying to make this box that I showed you earlier, right? And I had these flat wall panels, right? The thickness of the panel in Tinkercad doesn't actually matter. Like right now, this is set to be 20 millimeters. But if I put in 3-millimeter wood in my laser, then this panel, if I cut it, would actually be 3 millimeters. So you have to remember that, we're using a 3D editor to make our designs. But again, as we download these things, it will see what's touching the work plane. Now, something that I've been doing to make my life a little bit easier here is I've been changing my view a lot. In that when you're designing in 3D, you often need to change your view to be able to see things accurately. So I'm orbiting around, I'm looking at things differently here. And when we design in 2D, something that we like to do often is we like to, let's say, look at the design from the top view. So I might click on the word top here. But you'll notice that there's still 3D shadows happening. And that's because I'm still, even though I'm looking at it from a top view, I'm still in a 3-dimensional perspective. So something that I can do is toggle my perspective right here by pressing this button at the bottom of my sidebar. And if I switch it to orthographic view, watch what happens to my shape. Specifically, look at the side of this cylinder here. It will flatten the cylinder. And it puts me in a 2-dimensional perspective view, which makes looking at flat designs a little bit easier. So it allows us to design things more simply. It allows us to design things from a 2-dimensional perspective, like what a laser would see. And if I orbit around, if I'm in a perspective view, everything looks kind of funny. So we want to make sure that if we're working in 3D like this, we're working in our 3D perspective view. So everything looks as it would if it was in the real world. And if we want to look at something from the top, we switch to our orthographic view so it represents what it would look like for our laser. Something else that's really, really handy is that lasers are very accurate. They're very accurate machines, which means that we can really put pretty accurate and tight tolerances. So what I just grabbed was the ruler tool, and I dragged the ruler out to the corner of my shape. And we can use the ruler tool to accurately place dimensions on all of our shapes. So I can not only put dimensions on the parts, I could use the ruler to set dimensions and distances between parts. So like, for example, because I have the ruler in the corner of my shape here, I can set the distance from the edge of my hole to the edge of my plate to be exactly 15 millimeters, and you'll notice that it's moving it around. You also notice that right now it's measuring from the edge of my cylinder, but I can toggle between using the edge or using the middle. So now I'm setting the dimensions to be from the center of the cylinder. And I could, let's say, for example, I wanted this to be 15 millimeters from this edge. I could always move my ruler over to this edge now and flip the ruler around and then use the ruler to set the same dimensions on this side as well. So because our lasers are quite accurate, we can strive to make really accurate and well-dimensioned designs in Tinkercad as well. And using the ruler tool is a great way to do that. Another one of my favorite tools to use when designing laser cut projects, especially for making boxes, is the duplicate and repeat tool. So let's say that I want to make a box where the panels sort of interlock, right, rather than having to use glue. Well, what the duplicate and repeat tool does is it allows me to not only make copies of shapes, so bear with me for one sec, I'm just going to make one little tooth here for my box, right? So here's my first tooth that's going to overlap, kind of like a dovetail joint if you're familiar with woodworking. And I want to make a bunch of copies of these, but not only do I want to make copies of these, I want to make copies and I want to move them. So I'm going to press duplicate and repeat, and let me just set this to be a specific size. Okay. I'm going to press duplicate and repeat, which is right here. And I'm going to move this piece 20 millimeters without letting go. So without clicking away, I just moved it 20 millimeters. Now, when I press duplicate and repeat, it not only copies this piece, it copies and moves it the same distance. So it moves it 20 millimeters. And then, of course, I could copy these and bring those over there, and maybe copy them and rotate them and bring them over here, and then bring them over here, and group all these pieces together, and I have a nice little dovetail box where if I then grab the second one and flipped it around, these box panels would fit really nicely like that. So duplicate and repeat, really awesome tool. Not just for laser cutting, but I find that we do a lot of patterns and types of cuts in typical laser cutting projects, and that tool is super handy for that. And another really cool thing that you can do, which we actually talked about in our Artscapes webinar a little while ago, which was importing SVG images. So we can press this import button and we can import SVG image files. And give me one sec, I'm going to drag and drop one right on here. All right, and SVG image files can be made in a lot of different programs. For example, we're going to make them in Tinkercad, but you can also make them in other types of photo and graphic design editors and things like that. You can also find SVG images that are free for use all over as well. And this is just the recycling symbol that I've imported, and obviously it's a really accurate logo. I think this would be a rather difficult shape to make in Tinkercad, but I could import this image and let's say set this to be a hole and group it. And now when I would download this for laser cutting, this would now have this nice logo here that I could then go ahead and cut out of my box panel by importing that type of image, so SVG file types. It's also important, I set this to be green just because it reminds me of recycling, but it's important to note that color wouldn't transfer. Again, when it downloads this design, it downloads just the bottom profile. It doesn't know that this is green or whatever the color it is. That would come from the material. So if I were to put green acrylic or green plastic into my laser to cut this panel out, it would then be green. But the file won't distinguish color in your design. It just downloads, again, whatever is touching the work plane is exactly what will be downloaded. And if I wanted to, let's say, for example, distinguish between cutting and engraving, so I might want to cut this outer edge, but engrave this inner recycling symbol, like burn it and etch it. That wouldn't happen here in Tinkercad. You would set those settings later on in the CAM stages, which we'll get to in just a moment. Now, if I want to download this, I would hit export. And I could click SVG to download this for laser cutting. And then I could bring it into my laser cutting cam, which I'll show you in just a moment. Before I do, I want to show you a couple useful tools in Fusion to do something similar. So I know I have a lot of high school teachers with me here, so you might be considering Fusion. So let's say, for example, I want to send this to Fusion. I could click Send To. I could select Autodesk Fusion. If I wanted to, I could rename the file. If I was sending it to, let's say I was a student, I was sending it to a class or a Fusion team, I could choose that here and I could send it to like Mr. E's period 1 if I was a part of that. And something that's new actually for Fusion is sending with design history, which will not only send the file, it'll send all the individual shapes that I created too. So I can actually go back and manipulate my Tinkercad design. So I'm going to send this and let me switch my screen here. Give me one sec to head over to Fusion. Here we go. All right. So here is my Autodesk Fusion, right, that I have going on here. Oops, let me make this full screen. All right. And here's my part, right? So here's my Tinkercad model, my Tinkercad design that I've imported. And as I mentioned, I have this design history, which is down here at the bottom. So let's say, for example, I want to go back to before I grouped all these shapes together. I could do that. I could come back to this part and notice that all of these boxes are individual boxes that I have here before they were grouped. And that's actually a new feature. But when you bring something into Fusion, you can manipulate it. So let's say, for example, I wanted to, make something thinner or thicker. I could do that. I could add to this. So let's say that I wanted to, round my corners. I could add a round on them. I, of course, could access all of Fusion's design features to manipulate my Tinkercad designs. I'm going to make a new Fusion design just to show you what if we want to start from scratch. So this is a brand new Fusion document. And to start designing something new in Fusion, what we would do is we would start a new sketch. So I'm going to click this Create Sketch button and select one of my work planes. So I'll just select the top work plane. So we're kind of looking top down on our part, just like we did in Tinkercad. And I could use any of these sketching tools to design something. So I might grab my rectangle tool and set a box. And I could use the dimension tool to set dimensions, not 10. I meant to say 100, like this, right? Let's say that I did want to do the same type of dovetail pattern that I did in Tinkercad. Perhaps I draw another box over here where maybe I set this to be 10 millimeters by, let's say, 3.175 millimeters. And we have a pattern tool in Fusion. And I know I'm doing this rather quickly, but this is more to give you a sense of the differences between Tinkercad and Fusion. You can see that in Fusion, we can create sketches for everything that we would typically do as we go here. And in Tinkercad, you would start with a 3D shape, which differs, right? So in Fusion, we're not starting with 3D shapes. We're starting with a 2D sketch that we could turn into a 3D shape if we wanted to. There's lots of different tools for sketching shapes, for patterning shapes like this. You'll notice that because I drew a big box and a little box, these parts are not connected. So if I was actually going to laser cut this, what would happen is these little dovetail pieces would cut right off because there's this line here dividing it. But then I could use my trim tool to, let's say, cut away and turn this into a solid piece like so. So I could actually cut out this dovetail shape. And there's also some other useful tools like a mirror tool. So let's say I draw a line right down the center here. I could then use my mirror tool to say grab all of these dovetails on this side and mirror it across the center. And that would give me my dovetail box. And there's also a lot of other tools in Fusion. So one thing that you might find is you have a lot more text tools in Fusion than you might have in Tinkercad. Just a much more advanced text editor as you go with access to whatever fonts you have on your computer, which is also great, as we have here. And of course, I can kind of manipulate those things, right? And if I wanted to, I also could, let's say, make a bunch of copies of these, right? So let's say that we want to make a box. I might copy this a couple times. Let's do this once more, like so. I guess I would have to do it one more time. You do need 4 walls to work your way around the box. And now I have my panels. Now, when I press the checkbox, that will complete the sketch. So here's my two-dimensional sketch. If I want to 3D print this, I might go ahead and extrude these panels so they had some height to them, like this. And then that way they would be 3D parts, right? But for laser cutting, as we know, all we need is a two-dimensional sketch. So this would be ready to be laser cut. And I could right-click on my sketch and click Save as DXF, which will allow you to bring it out of Fusion and bring it into another program if you want to laser cut it. But Fusion is not only a CAD program, it's also a CAM program, which means we can actually prepare our designs for manufacturing as well. And to do that, you would switch to your Manufacture tab. And here, we can actually say that we want to fabricate. You'll notice that there is a cutting profile along with milling for CNCs, turning for lathes, additive for 3D printing as well. But I could actually set up a laser cutting project, assuming that your laser cutter was compatible, right? So not every, your laser would have to be part of Fusion. So you might have to add your laser manually if it's not part of Fusion's library. So you do have to make sure that your laser is here in Fusion. And then I could actually say that I want to, let's say, cut these boxes. I'm sorry, things are just going to multiple laser cutter. Here we go. You can see you could also use a plasma or a water as well. And when I do this, I only selected the one for now, just for the sake of time here. But I could actually simulate and see that Fusion is set up to program a laser cutter to actually go around and cut out my box. And this is called CAM. Now, in most cases, though, your laser that you purchase would probably come with a CAM program that you could bring both designs from Fusion and from Tinkercad into. And I also just want to show you, I switched back to my slideshow here. Everything I've said live, there's also a slide for it. So I know that we're going through this kind of quickly, but when we send you these slides in our follow-up email, you'll notice that we have slides and images to support all the concepts that we are talking about in tonight's webinar live. So the difference between CAD and CAM, we've selected a really fun project from Instructables called Plywood Monsters, made by user Microsaurus. And we have the link for that we'll share with you here. And it's just a really awesome, super fun and exciting 3-dimensional laser cutting project where we can make these cute monsters by cutting out panels in separate parts and bringing them together. And the production process for working with the laser would be as follows. You start with your design in CAD, whether it's Tinkercad or Fusion or Inventor, one of your CAD programs. You would then prepare that design for cutting in CAM. You have to then set up your laser. So for example, put in the wood or the material that you're using, make sure that you have your ventilation hooked up, and then you'd go ahead and you would manufacture. Now, the difference between CAD and CAM is that CAD stands for computer-aided design, and that's where we design our parts. CAM stands for computer-aided manufacturing, and that is where we prepare those designs for manufacturing, as I just showed you in Fusion. So Tinkercad, Inventor, and Fusion are CAD programs. Fusion is both CAD and CAM. But as I mentioned, your laser probably has a CAM program. Lasers usually have unique CAM programs to their specific manufacturing model. So for example, this is a screenshot of Glowforge's CAM program here. And you can see that I've imported my box here to actually prepare it for cutting, like we did earlier in Fusion, which you can do as well if you imported and set up your laser in Fusion to do so. So for this Plywood Monsters project, you can see that we started in Tinkercad. This is the example Tinkercad design that Microsaurus shared in the Tinkercad article, which we just dropped the link for in the chat. So I could select the parts that I want to download, and then I'd hit export and download as SVG, like I showed you earlier on. I would then head over to my CAM program, and I would import that SVG file. Notice that it's not yellow. It doesn't save any of the colors from Tinkercad. And I could position it wherever I want to cut. This happens to be a brand new piece of plywood, but I might want to position it wherever there's space if I'm using a cut piece. And what you can see here is that we're setting, are we cutting? Are we engraving? So the difference between me cutting a Tinkercad design or engraving a Tinkercad design happens right here, where I would open up my settings and I would say, okay, I'm cutting this line, and specifically I'm cutting it out of 1/8" wood or acrylic or leather or felt or whatever it is the material is that I'm doing. So those settings, they happen at the CAM stages. Again, CAD is where we design our models. CAM is where we set all the settings for manufacturing. How would we cut it? What material we're using? Very much like if you're familiar with 3D printing, you might use a slicer program to choose which filament you're using and what speed you're printing it at. That's exactly what you see here, but for laser cutting. So we're choosing what material we're cutting out of, if it's being cut, if it's being engraved, that's all happening here. We then send that design to our laser and we watch our laser cut, which is a super mesmerizing way. And this is also, it's sped up slightly, but this is a very fast cutting process. I mean, it depends on the power of your laser. It depends on the thickness of your material. But in general, lasers are one of the fastest manufacturing machines. So cutting out a plywood monster like this really would just take a couple minutes to do, where 3D printing it, of course, might take 20, 30, 40 minutes, depending on the thickness and the settings of your 3D printer. And then again, we pulled some images from this amazing Instructable to show you that the next steps for this project would be after you cut out all your parts, you might add some paint, you might glue them together, and then you have these adorable plywood monsters. But I mentioned earlier on that these methods are super similar to what you might do for, let's say, a vinyl cutter or a water jet cutter or a plasma cutter. So the production process for working with the vinyl cutter is almost exactly the same. We'd start with our design in CAD, and you would download the same two-dimensional SVG file. I'd bring it into a CAM program for my vinyl cutter, not for my laser, which would again allow me to set the settings for the type of vinyl I'm using, whether it's like t-shirt vinyl or it's adhesive vinyl. I could then set up my cutter by loading the vinyl and manufacture it, and that would allow us to use the same Tinkercad designs, not to laser cut little plywood monsters, but maybe little sticker monsters instead. So again, these skills are very universally applicable. And so teaching, even if you don't have a laser, these skills can be transferred to a lot of different types of techniques. And that's a really exciting way for your students to apply their skills in a lot of different CNC production. So as I mentioned, we're going to share this slideshow with you in our follow-up email. And there's going to be a bunch of links. I saw some folks are saying, I want to learn more about Fusion. I need some more support for Tinkercad. So we've linked a bunch of different Tinkercad tutorials from our Learning Center, different challenges, different ideas and lesson plans, as well as the same for Fusion, all throughout the slideshow that we'll be following up with our slideshow here with all these useful hyperlinks that you can see. And of course, we want to thank you for being here and attending live. In this follow-up email, we'll make sure that we also send out our professional development certificate. So for your 1 hour of PD for joining us here, either this evening or this morning or this afternoon, depending on where you are in the world. So that'll be included. And before we dive into our Q&A, I'm going to hand the microphone here over to Nicole, who's going to tell you a little bit about some exciting events and things happening in the Tinkercad and Autodesk community.
All right, to start, I'll mention the Tinkercad challenges. As you can see, they've been going on for a little while now, and we always have one running and we start a new one every about 2 weeks. The current one that's going is the Desert Habitat Challenge, and it kind of goes along with the Make It Resilient contest, which I will talk about later, but it's about using the provided model to try to make a structure that could withstand the harsh conditions of the desert. And then you get to be creative. You, of course, don't have to use just the starter model. We expect you to bring in all kinds of unique ideas and just show us what you can create. And it's great to see what you guys are able to do with just the simple shapes that are in Tinkercad. And then next we'll talk about Instructables, which is a lot of fun. It has a variety of projects, but we also have a dedicated teacher space, which then you can take the projects that are on the site, and we have a bunch that are categorized by their grades and their subject. So if you want something that's for history for grade 6, you can kind of see what people have shared with the community, and it's kind of fun to see the variety of projects and how people have incorporated them to be worked with education. And then we also have contests. So we have a variety of contests running, and then we have some that are student specific. And one of them is the Green Future Student Design Challenge. And for that, we want you to think about the the challenges on Earth and how you can use design to create a healthier planet so we can all have a better place, whether that's reusing or renewable energy. And then we just need you to use an Autodesk Fusion as part of the design process. So you don't have to 3D print or laser cut or anything. You really just have to use it to help you think of your design. So it's really open to what you can do with it. And then next we have engineering in the kitchen. So this is kind of a fun one. We have three that are running along with the semester. So this is one of them. And we want you to think about inventing something new for the kitchen, new gadgets, because there's always new things people are trying out in the kitchen. And we want to see how you can make something to make it easier for everybody. And then next we have made with AI. So AI, as many people know, has become more and more popular. And there's a lot of fun things that you can do with it. And so for this contest, we really just want you to use some type of AI in your design. And that could be generative design that's in Autodesk Fusion, or it could be the large language model like ChatGPT. There's really a lot of options for that out there. And we want to see how you would want to work with it. All right, and the last of the semester ones is the remake it one. And so this is all about taking something that already exists and kind of reinventing it and making it something new because it's important for growing. A lot of people think you have to make something new from scratch every time, and that's just it's too narrowing. There's always a way to build on an idea. And a popular example is the spork. Yeah, you have a spoon, you have a fork, why not put them together? And then you have something neat that takes up less space and there's just so much more you can do with reinventing something that's already there. And then lastly, we have the Make It Resilient contest. So this is a big one we have running right now. We're giving away a total of $50,000 in prizes, and this includes two $10,000 scholarships, four $5,000 scholarships, and 10 $1,000 scholarships. Now, this one is limited to the US and Canada, but as I mentioned earlier with the Tinkercad challenge, this is about making a habitat for an extreme environment. So the challenge that we had on Tinkercad going right now is just for desert environments, but this can be any extreme environment. So just helping people survive in the different ways that Earth makes things difficult, whether it's too cold or too hot, or you can't breathe because you're underwater, like how can you make it better? So we're really excited to see what people come up with this one.
Awesome. Awesome. Thank you so much, Nicole. I appreciate that. And somebody was asking questions about the duration of the challenges. And one of the things that we recently shifted is that we have been trying to align our challenges up with semesters. So, for example, have a challenge that might span from late January, February-ish to May. So that way it might align with a semester-based course or a half-year course, or even, let's say, a marking period within a semester if you have marking period-based courses. So we just started that for the spring, but we're looking ahead that we'll be doing some of the same in the fall as well. And then in terms of region, I believe, Nicole, are apart from Make It Resilient, are they worldwide? What about student accessing these contests?
Right. All of them are open to everyone except for the Make It Resilient. And it's only limited by, I believe, what they say, like anyone that has an embargo with the US. That's the only one where we can't really do anything. We just can't do anything with them. Otherwise, they have it open up to pretty much everywhere in the world.
Perfect, perfect. Thank you so much. That's excellent. And looking ahead, before we open up our Q&A, we have another webinar coming up in 2 weeks, same place, same time, called Building Digital Skills for Architecture and Construction. And we have some guests coming in for that one to talk all about the architectural and construction industries and how students can kind of gain skills and aptitude for that, which will be super exciting. So something that I think we're all looking forward to. And again, we want to thank you all so much for being here. So much for joining us live. We saw lots of great questions. We saw lots of great feedback from one another, you working through the chat and things and answering questions like that. So huge, huge thank you to all of you for being here and joining Nicole and I for another Design and Make webinar. And again, a big thank you to Nicole, and not just Nicole, but of course the whole community engagement team at Tinkercad and at Autodesk to help provide all the great resources that we were able to talk about with you tonight or this morning or this afternoon, depending on where you are.